let's talk about how we know that the universe is expanding. This is an idea that's really only been known for about 90 years or so. So back in the early 20th century, Edwin Hubble used Cepheid variables to figure out that there were other galaxies other than our own. And then he wanted to use the Cepheids to figure out the actual distances to these other galaxies, which he did. But then he also wanted to figure out how they were moving. So he was able to use the spectrum of the galaxies and to use the concept of the Doppler shift to figure out whether the galaxies were moving toward us or away from us and how fast. And he took both pieces of information, the motion, the velocity of the galaxies, and their distance, and made a graph. Here's my crude representation of that graph. So here we have distance, and here we have velocity, or the speed. And the first weird thing he found was that almost all of the galaxies were moving away from us. In terms of the Doppler shift, we would say that they were redshifted. The wavelengths of light were getting longer because the galaxies were moving away. I mean, why are all the galaxies moving away from us? I mean, do we smell? We took a shower today. Do we have cooties? I mean, what's the issue? So all the galaxies are moving away from us. And he found that the further away the galaxy is, the faster it's moving. And that's known as Hubble's law. And this is a very important discovery for two reasons. First of all, it is the first direct evidence that the universe is expanding, right? So I have a balloon here, and on this balloon, I've put some black dots. If I blow it up a little bit, the dots are now a little farther apart than they were when there was no air in the balloon. Blow it up a little bit more, the dots are further apart still. Again, the more I blow up the balloon, the farther apart the balloon dots are from each other. Okay? The farther, and if you measured how the distance is changing between these dots, you will find that the farther away the dots are, the faster they appear to be moving away from each other. It's Hubble's law. It's like blowing up a balloon. Now, this analogy, like all other analogies, is not perfect. Again, we're representing a space-time by the surface of this balloon, just like we were representing space-time by this flat sheet before. Also, as we blow up the balloon, the dots actually get bigger, as well as getting farther apart. Now, in the real world, the galaxies are not expanding with the expansion of the universe. That's because the self-gravity of the galaxy is much stronger than the pull of the universe trying to pull it apart. Another thing that we need to understand is, yes, there is a center of this balloon, but there is no center of the universe. All the galaxies are getting farther apart from each other. And it's not the galaxies that are physically getting up and running across the universe. It's the fabric itself. It's the very fabric of the universe that's actually stretching and getting bigger, carrying the galaxies along with it. Just like as the balloon is expanding, it's carrying the dots farther away. It's not that the dots are not running around here like ants. Okay? So again, we see all the galaxies moving away from us. But if there are alien astronomers in other galaxies, they would measure the exact same thing. As the universe gets bigger, all of the galaxies are moving apart from each other. There is no center of the expansion of the universe.